Hello, this is Beth Linden from AWS Educate. Thank you for joining the Educator Mobilization webinar series. Educators all over the world are rapidly transitioning to remote learning, and some for the first time. So we wanted to do something to help ease the transition. This webinar series was created for educators by educators who have expertise in remote learning and can share their insight with you. The series runs through May 1st. Hello, this is Beth Linden from AWS Educate. Thank you for joining the Educator Mobilization webinar series. Educators all over the world are rapidly transitioning to remote learning, and some for the first time. So we wanted to do something to help ease the transition. This webinar series was created for educators by educators who have expertise in remote learning and can share their insight with you. The series runs through May 1st, so check back on the website each Monday to review new webinar topics. You'll be muted during this webinar, however, you can put your questions into chat at any time, as we have set aside time at the end to answer questions. And with that, I'd like to introduce Dr. Perry Beaumont, lecturer at Columbia University and head of data science at Distinguished Programs. He's here to discuss the remote learning opportunities with data science. And with that, Dr. Beaumont, I hand it to you.
Well, thank you very much, Beth, and please allow me to say how terrific I think it is that AWS Educate is sponsoring these webinars, and so very pleased to be a part of it, and thank you so much for having me. For the agenda that I thought that we could go through today, first off, a few introductions, talk a little bit about what is data science, specifically address that in the context of remote learning, move on to some specific examples, and let's do this. Let's take some of these different ideas that we'll be talking about today and think creatively about putting them to action, including some next steps that can be taken immediately following the webinar for anyone who would be interested in doing so, and also leave some time for some Q&A at the end for any specific follow-up that anybody on the call might wish to offer up. One of the things I would certainly add as well by way of introduction is that I am so passionate about this topic today and really look forward to any opportunity really to share some of the things that I'm looking at in the business world through my position as head of data science at Distinguished Programs, which is an insurance MGA based out of New York City, or through the academic side of things as a lecturer at Columbia University, and to really bring the best of those worlds into any kind of context that might be of interest to folks to learn more about. My latest book in this area was entitled Digital Finance from Routledge Press that was just published last fall. I hold a patent in data-related algorithms, and in the context of AWS solutions, really interested in cloud computing topics, and I would love nothing more than to stay in touch with any of you who would like to talk about any of these things in greater detail, and please feel free to reach out to me with whatever is most convenient, Twitter, email, LinkedIn, what have you. And with that, let's jump right in. So what is data science? There's so many different ways really to define this, and in the process of putting together various ideas for today's webinar, I came across this particular definition, and I'll share with you the author in just a few minutes. But I like the idea here of thinking about data science as involving processes and systems to extract knowledge or insights from information, and either structured or unstructured. And while probably most of the things in that definition are certainly pretty straightforward, two that maybe perhaps are not would be this idea of structured or unstructured information. What do we mean by that? So one way to think about structured information, to make it really simple, would be, say, anything that you could put into an Excel spreadsheet. So numbers or certain data labels or things like that. Unstructured data, which is becoming more and more popular as an area of study for data science, we can think of as kind of everything else. So photographic images, sounds, satellite photographs, anything really that does not maybe lend itself to putting into a cell of an Excel spreadsheet can maybe be thought of as being unstructured information. And the idea of data science generally then is, regardless of what the information is, regardless of the particular context that that information might be presented within, we love it. We want to study it, we want to analyze it, we want to know more about it, and we'll cast a really wide net to capture all the different kinds of information out there that we could use for thinking about ways we can apply it to interesting insights for whatever might be a particular interest to us. Another way that I like thinking about data science is that it really is more than numbers. If we might think of data sometimes as being numbers, it is that, certainly, but it's really much more than that. And in this particular data science life cycle graphic, it touches on a lot of the different things that are involved with data science, where there's really something for everyone. Even if you don't consider yourself a data person or a numerate person per se, we still need you in data science. We still very much want to embrace what you have to bring in the way of your ideas and insights, because data science is so much more than just the numbers in the database that we're looking at. So it involves, for example, things like data discovery, and that can involve people who can simply be really creative and think outside of the box in terms of different types of data and information that might help us to solve a problem. So you don't even necessarily have to know where to put your hands on to get the data, or how to manipulate the data once we have it in hand. Even just thinking about how can we go about identifying who might have this information and how we can get it from them to do analysis and to get insights is a very important job. And there's a lot of people who are really creative with thinking about those kinds of research elements that are so fundamental and important to the process, who can make a great contribution with that. Data preparation, helping to think about what's the data that we might want to use that's structured versus unstructured. How do we organize that? How do we catalog that? Then we certainly do enter some areas where having that kind of math interest or programming interest can certainly become very important. So mathematical models to try to come up with different ways to express in sentences using code rather than words, to try to identify what we're doing. Getting things in action. So here's where people who are really good at organizing or thinking about the 10 steps that are needed for success with a project are really helpful and really beneficial to looking at data science kinds of initiatives. And then finally, communicating. Who are people who are really good at taking a complex idea and breaking it down into something that's really straightforward and easy to understand and easy to help others to see. Maybe it's with words, but maybe it's with a chart or a picture. And again, people who have those kinds of interests and skills may not necessarily be the people who are going to be writing the mathematical models, but we need persons who really like that aspect of looking at solving problems, to know how we can take the results that have been worked on so hard to create and then share them with others. And if you're someone who enjoys all of these things, from collecting data to the modeling part to the communicating part, then gosh, data science is really for you. But if there's some things that you really just have an interest in, maybe more so than another, you definitely have something to bring to the table and can definitely be a part of the conversation. So in terms of thinking about data, it is so readily accessible today. There are so many places where data is available and available free of charge as well. So just kind of moving left to right here on the top tier of data sources, I would like you to meet FRED. FRED is an acronym for the Federal Reserve Economic Database. And there are over 500,000, 737,000 to be more precise, given the splash page of FRED, of all kinds of U.S. and international data sets that are freely available for people to access and to use for asking all kinds of interesting questions where data can be helpful, and then using those. Another data portal, again, freely available, is the Chicago data portal. And there is another one that's also available from New York City, another one for Seattle. In fact, there are several all across the country where municipalities are increasingly realizing the power that comes from making freely available all kinds of statistics that are collected, and then making that available for people to look at it, and then actually help these cities make better decisions about things like urban planning, or maybe based on the frequency of 911 calls, where more city resources might be located, or how different schools might be set up within various districts, and getting better resources for them as well. And then the other one that I have on the far right there is an open data portal initiative of the European Union, where again, there are literally thousands of data sets available to explore and to evaluate. And a reason why I have a couple of maps here at the bottom of this particular page is because an increasingly popular area with data science is bringing in geography. And there are some really cool things that are happening in the world today in terms of using data in the context of geographical perspective. So for example, in this map on the lower left, it's one that's generated by a company called Kinsa. And Kinsa is a thermometer company. They manufacture thermometers just like we would use at home or at a doctor's office, but with one unique twist, and you wouldn't even know it if you held the thermometer in your hand, and that is the thermometer has Bluetooth technology, the same kind of technology that allows you to drive hands-free with the connection in your car between your cell phone and the car devices. And every time a temperature is taken, that temperature reading is automatically sent by way of Bluetooth technology to Kinsa databases, where they then record it and make it publicly available to see what temperatures are of people all around the country. And as you might imagine, in the current context today with COVID-19, this is a really interesting tool to look at, to record on a day-to-day basis and look how things are evolving a week at a time, a month at a time, thinking about what are the attributes of certain geographical areas that might suggest where other resources can be brought into play, or different things that are at work. And then it's certainly, of course, even when we do get beyond the COVID-19 pandemic, so many other applications of this for public health benefits. The chart on the right is one that's actually made available by NOAA, the Federal Weather and Aviation Service. And this particular chart shows energy expenditures across the country, red being more intensive, yellows being less intensive, and really giving us an idea about how things pertaining to climate change are affecting decisions about costs of energy, leading to some creative thinking about what can be done in the way of alternative energy sources, and how might those be placed, and how might those be used to making better decisions relating to energy over time. And what I'll do here is just pause a minute from slides and share with you a couple of these online, and the different ways that these data sources can be accessed, and the kind of information that they can help to provide to us. So in this first one here, we have the case of Fred. And again, kind of just scrolling through here of the different data sets that are available. I'll click on here, the Consumer Price Index for the US. So this gives us a measure going back to even before 1950 of how prices have been evolving in the US over time. And if I want to, I can edit this and add other data series to see how those might look alongside. So maybe I'll pick, say, for example, what's going on with the Consumer Price Index for Japan. And we can add that price series and see how that might look in terms of the performance in the economy of price changes for Japan relative to the US. And I'll also, just for good measure, throw in the United Kingdom and their Consumer Price Index and see how those three data sets relate to one another. As we think about more and more global trade, for example, and how many economies around the world are becoming more closely aligned with one another and integrated with one another, it might be interesting to see how these relate. And as you can see, as I hover over those lines there, we get specific values that are emerging. Another thing I'm going to do here, just to make it a little bit more interesting, is I'll click on percent change from a year ago, and I'll say copy to all, so automatically looking at the percent change in prices year over year for each of these three different parts of the world can now be analyzed, and with all of them being shown at once, and we can really kind of see here this kind of convergence from where we had more of a dispersion or difference in, say, the 1970s and the 1980s, where today we really can think about economies becoming more closely related. And if I want to download this in the form of an image or a PowerPoint slide or even Excel data, I can do that too. And here we have GeoFred. So here we can look at, again, many different types of data and show it in the context of how it might look in the presentation of a map where we have all the different counties of the US laid out here. And again, if I want to pick download and have it download into a spreadsheet or a PDF or a picture file, I can do that as well. So here we have Chicago Data Portal. Here's building permits. We can click on that and see that there are thousands of data elements recently updated just from a few days ago, so really kept current. 620,000 rows of data for looking at different questions pertaining to that. Here's the US Census website. Again, different graphics, different tables and such that are available. Here's a really cool product that I think is really interesting to look at. It's called Experimental Data Products, again, from the US Census website. And they will actually provide access to data sets that they are in the process of developing. And they're always looking for insights and feedback about, hey, what can we do better? What might be more interesting for us to provide for people who have an interest in these topics. So a great place to check out. So let's now then go back to the PowerPoint. And moving on from data being readily accessible to talk about platforms. In other words, different ways you can take that data that we can obtain and then put it into a context where we can actually do some analysis with it. And again, a lot of interesting things out there that we can make use of. So for example, in the upper left here, we have Sales Handy. This is a tool that's available for free to look at analysis of an email campaign. Maybe you have a relative or a friend or someone who might be interested in thinking about how do they make their email campaigns more effective. Are email campaigns more effective if they send the email out in the morning part of the day or the afternoon part of the day? Do they get more people opening it up based on if there is some kind of a coupon offer inside, or if there's a free download for something to look at that might be included. This is a tool that can help track and do analysis with all kinds of things relating to that. So any interest in marketing and business and communications, that might be something fun to check out. GitHub, again, a great online free resources with all kinds of platforms available for putting data, especially very large data sets that may not even fit into an Excel spreadsheet, into different contexts for analysis and exploration and asking a variety of what-if questions. And then also with AWS, with Amazon AWS Educate, some really great resources, not just in terms of platforms, but also there is a open data registry of all kinds of amazing things to check out there as well, including satellite photographs that are readily available for download, and then with a lot of ideas for different platforms for how those can be analyzed as well. And also a lot of really very helpful and interesting online webinars, and again, at no charge, as well as recorded videos of taking you through from step A through to step Z about ways to go about setting up a complex or large database environment for doing analysis and what have you. And if you remember my mentioning at the closer to the beginning of the webinar of the definition that I selected for what is data science, I actually took it from this particular introductory online tutorial available in AWS. And it's really a great tool to use for self-paced learning on a variety of different topics. So let's do this. How can we get started now with these different ideas about data, about platforms, and things that we can analyze? So what might be some sample questions to explore? And by the way, all of this is remote. All of this is available online to fully from beginning to end evaluate, play with, work with, all with online resources. So some sample questions to explore might be, what is the relationship between various types of email campaigns and the sales of the firm, where again, maybe a parent or a relative or a friend of yours works, and helping them out with thinking strategically about that. Another question, what is the relationship of population density, which is one of the data elements available from census.gov, and various metropolitan data elements. So we can go to the Chicago data portal and the New York City data portal and the Seattle data portal, and we have 3 representative cities, one from the East Coast, one from the Midwest, one from the West Coast. How do certain elements of aspects of city planning or what have you compare, contrast? How do those relate when we compare them to other population densities, maybe more dense or less dense populations available to us through census.gov? What do those look like if we put them in the context of a mapping perspective available through Fred or other sources available for doing that? How can satellite imagery be used to predict the evolution of the Earth's surface as related to climate change? So those satellite images that I mentioned a moment ago, available through the AWS data repository, they go back a number of years now. So it could be most certainly possible to kind of observe over time what various coastlines are doing or how they are relating from one part of the world to another, from one hemisphere to another, with the benefit of those. So in that particular context, data science could involve not necessarily having to put a lot of data into a database, but just observing, taking a really close look at what's happening in our world with the benefit of data coming through the form of images, and what can we learn from those. Another question, can certain types of demographic data be used to identify relationships with the frequency of particular medical conditions? So one of the data sets that's available through the AWS depository is actual medical information collected. There's thousands of records that look at data that has been made anonymous, of course, based on different types of patient ages and different conditions that they present with, and ways to think about asking interesting questions about correlations or relationships that might exist between one particular type of medical situation or another. Another question, what might be a new product for the new field of parametric insurance? So what is parametric insurance? Well, parametric insurance is this idea that maybe an insurance policy can be designed around the idea that if there's a certain metric that occurs with a certain frequency, that would give rise to insurance protection. So for example, let's say that we're talking about a part of the country that can experience really cold temperatures during the winter. So states like Massachusetts and Maine and New Hampshire. So one idea of a parametric insurance product might be to say, hey, if there are more than 20 days in a row where there are freezing temperatures below a certain degree Celsius or Fahrenheit, then that will automatically generate for you an insurance payment of X amount of dollars because of the idea that those persistencies of really cold weathers tend to be related to things like not being able to get out of the house because of temperatures being so cold and not being able to have certain things be completed, or they might be associated with pipes freezing and some things that can happen with that, or any number of different things that can be related to weather events, or any different kinds of things that might be related to things that we can measure. So what's your idea for a brand new type of product that can be related to things that we can count, things that we can measure, related to weather events or what have you, that you can propose as a new idea? So to pull this all together then, as a remote learning opportunity. So either for instructors out there who are thinking about coming up with an interesting exercise for your students to think about, or if you're someone who is just interested in learning more of this, something you can certainly do independently, here's 4 steps to get you on your way. So number 1, visit the open data resources of a couple of cities that you think might be interesting. Think about some things you might want to compare and contrast between the two. Step 2, take a look at SageMaker within AWS or any other resources there, or any of the other platforms mentioned in the webinar here, and deploy a machine learning project that will take you through step by step about how you can do that. Step 3, there are so many different resources out there available, again, online to walk users through how to achieve the ABCs of some basic data analysis. There's the different resources made available by the respective providers of these tools. There are also YouTube videos that are created, online forums where all kinds of questions can be posed, and you don't have to be concerned with how simple or basic you think it might be. And chances are, if you have that question, I bet somebody else does as well. Just go ahead and ask away, and you'll find, I think, a very welcoming, warm community of people who want to help others, especially those getting started with getting the basics and where to go to get answers. And then finally, if you chose this particular idea of comparing database elements of a couple of cities, share your insights. Hey, maybe you can let the city planner know for Seattle, hey, I came across something here that I thought might be of interest to you. Just wanted to share it with you. Or with regards to the census.gov website with the experimental data that they provide, shoot them an email. They provide their contact information at that same website we reviewed a moment ago, and let them know, hey, I really enjoyed this experimental data set you put together. One question I had was what have you, or hey, here's a suggestion about maybe how it could be made where there's some improvements or what have you that could be done, and contribute in a very meaningful and positive way to making the next person's experience that much better as well. So many different ways to put what you might be doing and learning and discovering to the benefit for others who will be following the work that you're doing. So with that, why don't we take a moment here to allow you to provide any questions you might have, and please just step up to provide answers for those. And with that, I will turn it back to you, Beth.
Thank you so much, Dr. Beaumont, for sharing your expertise on data science. I learned quite a few tidbits and some new tools as well. Thank you to all the participants who joined us today for the webinar. We hope this information was really useful for you as you transition to online learning. As I mentioned earlier, we will be hosting webinars through May 1. We're also hosting office hours to answer any further questions that you might have. You can find that information for both the webinar series and office hours on our webpage at awseducate.com. Now we're going to answer some of your questions in chat. Thanks so much for joining and have a great day. Dr. Beaumont, it looks like we might have a couple questions here. One specifically about best practices for remotely teaching data science. And I wondered if you could maybe provide just a few best practices that you've employed in your classes.
Absolutely. And you can hear me okay, Beth?
I sure can.
Okay, terrific. Yeah, I really love that question. And one of the things I would say that's really been very successful in my experiences and shared by other colleagues as well in terms of best practices is this idea of allowing plenty of time for things to bubble up and surface in the way of ideas and having students to work through the different things that they're working on. In other words, if it's a choice between, say, what might be a very contained, like 1 week type of assignment versus something that might be able to span an entire term or course, I would definitely vote more in favor of the latter, of having ample time. And I think that there's a few things that are such great positives in taking that approach. One is I think you'll really see some amazing things coming from the students themselves when things are over a greater period of time, where they begin to help each other in a variety of ways. Maybe it's a particular data source. Maybe it's a particular way of setting up a hypothesis of something interesting to study and to look at. And before you realize what's happening, they've set up a chat room and place where they can get together and exchange different ideas online about what they're encountering, what's working, what's not, what some next steps might be. But overall, it's this idea that when it's possible, when it's practicable to do so, to try to maybe come up with something that might be an overarching theme that would be something you could touch on over the course of a particular class that you're teaching in this area, and allow for ways to have more of an in-depth way of engaging with it and looking at it, rather than something that might be thought of as being something more just kind of tick the box kind of an experience. And that in those initiatives where the projects are a little bit more broadly defined and go on a little bit more deeper into things, that there just tends to be that much more excitement and involvement by the students themselves in the whole process.
Absolutely, Dr. Beaumont, that makes a lot of sense. And in some ways that answers another question that came in about your thoughts on a reasonable time frame for a particular data science project from start to finish. And it sounds as if the longer duration might give you better results, is sort of what I'm getting.
Yeah, I think that's exactly right, and I think it's also relating to how things might be set up. So, for example, I guess to borrow from the first word of in the context of data science, the idea that we can bring in scientific method. For example, we observe something, and then after we observe something, we try to set up a hypothesis about it. What might this lead to, or what might this be about? And then we experiment. We actually collect information and evaluate evaluate it, do some analysis, and then come up with a conclusion, and then maybe retest some things or what have you. So if it's a situation where maybe as an instructor you're coming into the course at the beginning, where you've already identified the problem you want the students to work with. Maybe you've already identified the data set to say, okay, this is the data set we want to look at now in terms of what hypotheses you set up and how you want to approach it will lead to you, but you narrow it down a little bit. I've found that can be extremely helpful, and that might help with the time frame of things as well. Even if you wanted to go to the point of saying, okay, here's the data set and here's the hypothesis. Now, how would you go about trying to tackle it from here? That's certainly something that works as well. And that might take something that might have otherwise added another week or two to the process to really jump more to the collecting of the data, the analyzing of the data, and getting into that aspect of it. And for maybe a little more time constrained context, coming in with the data set and the hypothesis already would be advisable, and still be able to have the students get a lot from the experience.
Yeah, no, that sounds great. Now, if we consider our current state of remote learning and these types of projects, do you have an opinion about whether data science projects might be better assigned as individual projects or as group projects?
Yeah, that just from my own personal preference, I love group projects, because to me, one of the things that really makes data science so exciting is the aspect of collaboration. And with one of those first slides that I had shared, this whole wheel of different things relating to data science, where you don't really have to be a mathematician or a coder or a programmer to really have something insightful to bring, to think creatively about what the data might be saying, or when all the work is done, to have someone who's really skilled and likes the idea of taking a complex idea and explaining it well. That might involve skills that have less to do with knowing how to program in Python, and more how to relate to people and how to explain things in a way that somebody can get for the kind of jobs that they need to take on, and what have you. And it is so very easy today with a variety of, again, free online chat rooms and venues and places to share documents and pull them down, edit them, and put them back up again, and what have you. And this idea of working as teams, as working collaboratively, feeding off of each other's strengths, and testing one another in terms of what's working, I think is really a fantastic way to do it.
Absolutely. That sounds really positive. Another question that's popped in here: how can geographic data analysis help us to combat COVID-19? What are your thoughts on that?
Yeah, that's an excellent question, and I think that there's so many different ways already that are emerging with respect to geography and relationships there. One of the first laws of geography is this idea that things that are more closely with one another situationally tend to have much more in common with them than things that are further apart. And one of the things that's coming out is in relation to certainly population density. So when we looked at that map a few minutes ago through the Kinsa analysis, we do see such a heavy concentration, darker shades of reds and oranges in more highly populated states and areas, certainly metropolitan areas as well. But we're also seeing it in areas where there's not necessarily a greater population density, but where there are certainly important dynamics at play with demographics of age grouping. So one of the things that we were learning about this particular strain of virus is that elderly persons, unfortunately, are more predominantly affected in terms of being able to combat and fight against the virus than younger age groups. And we saw that kind of reflected as well in that map with many areas of Florida, which are more higher concentration demographics of persons who are older, maybe more retired persons or what have you in that area. And these are the kinds of things, not just with the current situation that we're trying to better understand and be better prepared for in the future, but for other things that might be coming along in the future as well, to better understand and maybe get some early warning indications by seeing something appear in a reddish color in one part of the country and being able to ask critically, okay, do we think that might be contained to that one particular area, or is it possible that it might spread somewhere else? Okay, well, what are the particular attributes, the characteristics of that area where something that we're seeing evolve in contrast to where those same type of attributes might exist in other parts of the country, similar age groupings or similar densities of populations or whatever the issue might be, and really get ahead of things in terms of saying, hey, with these characteristics and these symptoms, what have you, in this area, they're very similar to something that might happen in this other area. What can we do now to maybe kind of head that off? So it's a growing area of interest, and I think one with a lot of promise, and where we need a lot of young, great minds creatively thinking about how to use even more of these kinds of applications.
Yeah, absolutely. I was actually just speaking to a colleague about this current state that we're in globally, and how data scientists must be really eager, because there's so much data that we have been able to capture, and what they can do with that data, and dive deeper into finding patterns and potential resolutions, or like you said, heading it off at the pass, so to speak. So yeah, very fascinating, very fascinating. So I do have another question. It says, how do you execute a strategy for the data? What do you need to consider, or what goals do you need to put in place to make it work effectively?
That's a great idea and great concept to bring up. And I think that I would go back to this idea of a great strategy, a great rule book to work with, playbook to use with these kinds of thinking and context is the scientific method. What do we observe around us that we think is interesting, and then following the rubric from there. So taking that to the point of forming a question that would be interesting to try to answer, then trying to determine what is the information that we need to try to best support that, and approach trying to answer that question, and then how can we test that, and if maybe it's related to a statistics course, bringing in some concepts of how we construct confidence intervals around the data. Can we make the assumption that the data has a normal distribution to it or not, and the different tools that can help us with analyzing those types of things? Or maybe it's not really statistics at all. It's just trying to observe in the context of satellite photography. How do we see what really do seem to be perceptible evolutions in the changes of things that we're observing? But in terms of an overall strategy or way to kind of guide the thinking from start to finish, I think bringing that kind of science rigor that the scientific method allows us to do is a great way to think in a logical, progressive way of what would be required and what could be done to think critically about what we're doing, and to ultimately feel like we're following a path to get there.
That's really great advice. I think that's a really smart path to say. And I haven't heard the term scientific method since college when I took a biology class. So yeah, that's a great reminder to me. It looks like we have one more question just popped in. This is a really good one. Would you mind recommending some data science competitions? And for business students, should we spend a lot of time on math first to learn data science better?
Yeah, both both great questions. So in terms of competitions, yeah, there's all kinds of interesting things to do. If you were to simply do a generic search with your favorite search browser on that topic, there's a lot of things that are sponsored by various folks who are in the space of the data itself or the platforms. And one thing that I want to mention in that regard as well are MOOCs. MOOC is an acronym, MOOC, and it stands for Massive Open Online Courses. And that's where literally there could be a couple hundred or maybe even a couple thousand students at one time kind of focusing on going through one particular type of problem or technology or approach to using platforms and data together and what have you. And those can be a lot of fun to be a part of as well. And then the second part of the question about, business studies and almost and the idea of statistics and bringing in that kind of understanding of things. I think that the way of the future here is that it's really going to be increasingly just about taken for granted that someone who is in the business world or who has studied business is someone who has a good grounding and an understanding in the fundamentals and the basics of working with data. And not to say, a data scientist by any means, but someone who knows their way around a spreadsheet, who understands the idea of identifying data relationships where there appear to be correlations or relationships or not, how to present information graphically in a helpful way to people, and it will come to the point where it'll just be kind of naturally assumed that there's an ability to be conversant in those things in terms of how that relates. And one way I like to try to put it is how I think we're becoming more and more expected to be bilingual as business people. And what I mean by bilingual is not only to speak the words in terms of, hey, here's what's going on in this business and what's happening and the trends and the opportunities, but to be able to speak in numbers as well and to be numerate and to be comfortable with telling stories that are predominantly numbers oriented rather than word oriented. And anything you can do to add to your skill set to be like bilingual in that fashion through these different resources available and self-paced studies and online are only going to help you to be a more effective and more successful person in business or any field.
That's really great advice, and I love the bilingual statement. I think that's very true across many domains. Well, it looks like that might be all the questions in our queue right now. So I wanted to extend a big thank you again, Dr. Beaumont, for joining us and spending some time with us to share your expertise and passion in data science. Also extend another thank you to all the participants for joining us today. We really appreciate it. Go back and visit the AWS website to learn about other webinars that are coming online in the near future. So again, thank you so much for everybody for joining and have a great rest of your day.